2, boat with the initial speed 30 meter per second and decelerates 3.5 meter per second for 4.5 seconds before reach the buoy. Calculate the speed of the boat at the buoy. So now here the information given by the question is this is initial velocity and this is acceleration, but this is decelerate, and we have the time t 4.5 seconds. So to calculate the final speed or the speed of the boat at the buoy, you can use the v is equal to u plus at, and the value of initial velocity is 30, and the acceleration here is 3.5 because this is decelerate, so you must use a negative 3.5, and the t here is 4.5 seconds. So the final answer for the v is 14.25 meter per second. Hi, question number B. Figure show a stream of water hitting the wall with a height of 8 meter with a velocity 40. So meaning here this is initial position. This is u, right? And this is the angle 35 degree, right? And this is the height of 8 meter when the water hitting a wall. So calculate the initial. Yeah, what is the velocity of v here? So you look at the motion of the object. This is a projectile motion. So meaning if you have the u here, so meaning you have a u, you can resolve to the uy, or you can resolve to the ux. And to calculate the u, you can use the Pythagoras here, right? This is a triangle. We have a y square plus ux square. So for the ux, right? For the ux and the uy, so you must use the find the ux or uy by the using the equation, okay? But as you know, ux is always constant, meaning ux at the only point here, vx, here we have let's say vx, here we have a vx next, is always constant. So ux is equal to vx. The problem here is a uy. Okay. Oh, sorry. This is the 40 meter per second at angle 14 when the water hit the wall here. So this the diagrams is, this is here, right? This is v here is equal to 40 meter per second. So now here we can find this is a vx, and here we have a vy. Okay. So now, because as I said here, ux is always constant, vx or ux at any point at the on the part of motion, we have a constant value of the ux is always vx. So now here, if you, this is the angle here, this is a 35 here. So meaning here we can find the value of the ux is equal to v cos theta, and so we have v is a 40 cos 35. So this is, if you calculator, this is equal to 32.77, right? This is the ux, because the problem is because you want to calculate the u, so you must find the value of the ux square plus uy square. So this us has already calculated 32.77. So now the problem here is a uy. So to calculate the uy, so uy here, you can use the equation for here this is a vy. So vy is equal to v, because we have use a triangle here, is always cos 30, so this is the vy here, this is v sine 30. So theta is 35, so this is v is 40, this is sine 35. So if you use the calculator here, So the Vy here is equal to 22.94. This is Vy, and this is Vx, right? So this is 22.94, right? So this is Vy. So now you can find the value of the Uy here. So to calculate the Uy, you can use the equation Vy square minus is equal to Uy square minus 2gs. So you can find the value of the, here we have a Vy, right? So Vy is equal to U square y minus 2gs. So for the Uy is, sorry, this is not the Vy, so come on, this is Uy. You want to find the Uy, right? Sorry. So here we have a, yes, so Uy is equal to Vy square plus 2gs. So Uy is equal to square root Vy square plus 2gs, right? So now you have a value of the Vy here 2294, and this is G 9.81, and the S here is a 8, right? So you can find the value of the Uy, and the next you just put in the value of the Uy to the equation here, and you have a Ux here. This is Ux here to the equation here. So you can find the value of the U is 41.92 meter per second, right? Okay, and so this means the initial velocity. Yeah, so this is the 41 U, or initial velocity of water as it leaves the nozzles.